Hi, my name is Frank Hill, and I'm working on a number of Internet of Things projects, and I'm also doing some demos for web services. And what I'd like to do here is demonstrate how a microcontroller can be connected to a web server or web services, sorry, on the Internet. This is a microcontroller. Right now it's connected to a USB, but this device, which is a WEMOS D1, is also Wi-Fi, and with a 3.3 volt battery, I can have it communicate directly with a web service on the Internet. First, I'm just going to demonstrate the connectivity, and then in subsequent videos I will connect to some sensors. So let's get started. Let's discuss the means of exchanging data between the client, which can be a cell phone or a tablet or a microcontroller or any other computing device. Web API is a method of communicating that's not specifically designed for web browsers, even though you can use a web browser. It uses a protocol called representational state transfer. It uses standard get, post, put, and delete methods to access resources on the web. It can use XML or JSON to transmit data between client and server. JSON we're using in this example, and JSON stands for JavaScript Object Notation, and it's in a data exchange format. APIs are language independent. That is, you could either the client or the server could use, as in this case, .NET, C#, or Java, or PHP, or any other language. In this case, I've used Visual Studio for the basic API framework because it auto-generates a lot of the code that you need, a lot of the framework that you need to create your web service. Now, let's just look at a basic interface diagram between the client and the server. In this case, I'm showing a browser because typically you're going to use the browser to test the interface before you connect other devices. You can get built-in plugins to work with Firefox and other web browsers that will allow you to communicate and make sure your interface is good before you hook up your device. So, kind of standard request response interface. We send a request to a web server. In this case, it's IIS, which supports ASP.NET, and then a response will be sent back to the client browser. And I'll note in this case, in many cases, this is for debugging. If the API is found to work, you can then hook up your microcontroller or other device and be fairly assured that it's going to work sooner. It's a good debugging method. This is the code for a simple get operation from a ESP8266 type client to a web service that runs on the internet. And just going to go through a basic description of what happens here. At the top we see include REST client.h, and that includes a library which has all of the Wi-Fi functions needed to connect to the internet. We set a variable here of the type REST client to the variable client, and the location of that website is homecontrol.internetcontrolsystems.com. Then we go on to our setup portion of the code, which is typical for Arduino ESP8236 type processors. We do a begin to start the connectivity to the board, and then we print a line which can be viewed on the console that says connect to the Wi-Fi, meaning this is what we're going to do next. And here's the next operation. We start the Wi-Fi, and Hiltroni.study is the name, the SSID, and then there's a password. And then we print a message on the console that says the setup is complete. Next, we're going to declare this string response, which is a variable that we will hold the response once the operation is completed. And then we go on to our loop. We initialize the response to nothing. Then we make a call using the client object and doing a get. The method is get. The location on the internet domain is /API/home, and we're giving it the address of response, which is where we want to get our response once we complete the operation. Then we print a label which basically says the status code from the server, which we hope to be 200. Then we actually print the status code that we get back from this operation up here, and hopefully again it's 200, which means that we succeeded. And then we print a message that says the response body for the server, which tells you just what's going to be returned as a result of doing that get. And then we print the response, and then we do a delay of 1 second, and then we'll go through this loop and we'll do that all over again. Now the next thing that we do after this is we're actually going to show you this code operating and show you what the results are from this operation. Now you're going to see the results of executing the code that's on this processor board. It just happens to be called WEMOS D1 Mini, which is a small microcontroller. But I'll show you a picture of after I show you the code, and the size of it is approximately 3 inches by 2 inches. So let's just start the operation. We start by going to Tools, and then we're going to run Serial Monitor, which is a console screen that will let us see the output of the code executing. And here we go. We get a status code of 200 from the server, which means that we connected and everything is okay. And this is the body of the request that comes from the server. Okay, so you have that. So that shows that. I'll now show you what the device looks like, and subsequently I will connect to the web server and show you what the code looks like for the web service. This is a picture of the WEMOS D1 Mini. As 1.35 inches by 1.01 inches. It has 11 I/O pins, and it has 4 megabytes of flash memory, which you can actually get a lot of programming into. So it's a pretty nice little device and can be used for all kinds of application. Uses 3.3 volts, and with a lithium battery you can get quite a bit of time out of it. Of course, the application is going to determine how long the batteries last, but if you do a good job, you should be able to run it for a day. I'm going to show here the main code for a web service, and this web service can do a get, and it can do a put, it can post, and it can delete. And these are the major HTTP functions. We see up at the top here namespaces that are included, and these namespaces contain classes that are required for the web service. We see a public class here with the name home controller, and it inherits from API controller, and it's a kind of a template that gives or has most of the functionality that you need to implement the HTTP functions. And this is all provided by Visual Studio when you build the application. In this case, here's a get, and you saw in the earlier case where a new string was returned. Pump 1 and pump 2. This is basically just a test to see if there's connectivity. You can also use a method, a get method, where there's an ID, where this ID indicates a specific item that you'd like to get from the data set. The data set in this case is stored on a database, and it uses a custom class called home controller persistence, which the job is just to interface with the database. So we defined an instance here, and we give it this name HC, and this piece of code here actually calls the get pump and gives it an ID. This happens to be in the home persistence file. We'll go over here and look at it, and let's find it. And there it is, get pump, and it passes in an ID again. And first thing is done is to generate SQL commands that will extract the data from the database. This code actually returns the requested records, and then the results here is returned back to the home controller, which is the calling uh, class. Now I want to show you some other files. All of these files were generated by Visual Studio automatically, or these folders which have files in them, when the application was started up. And this is actually very useful, because if you had to generate all the files needed for the web service and understand what they were doing, it would be very hard to get started. Now, I'm only going to show you a little bit of code here sort of to give you an idea of how it runs, and in subsequent videos I will fill in the blank and do a better job on definition of terms. So I hope you like this video, and I will be coming out with other videos in the near future.